So this Feller-Delimber was, SATCO was a company in the North Island, and the guy was brilliant. Like he's probably one of my favorite clients just because he challenges the hell out of me. So what he did when he first was having problems is he called me, he said, I got your name from somebody. I've got a product out there in the forest, it's breaking regularly. We've sent the fitters out there a lot of times to fix it, and we've done a lot of work and it's still breaking, you know. I need some help, can you help me? And I said, yeah, sure, I can, you know, that's exactly what we do. So yeah, I'll be glad to do that. So where is it breaking? And he's like, well, I'm not gonna tell you that. You tell me. And I was just like so taken aback. I'm like, that is the best thing any client's ever challenged me with. I have to show him where it's breaking before he's gonna believe my process. And it was brilliant. So I said, okay, look, I'll go on this journey with you, you know. You give me all the models you have, and I'll do an FE, and I'll tell you where I think it's breaking. And he said, okay, well, here's what I got. So he gave me a bunch of DXFs. Anybody familiar with AutoCAD? Yeah, so they got all these 2D drawings, and you know, we try to go make a 3D model out of this, and we just find conflict after conflict after conflict. And so finally, and we're calling him, well, how does this look, and how does that work, and you know, and finally we get it all modeled up. And in that process, I had shown him 5 or 6 places where his DXFs were wrong, and where that was causing them consistent problems in their manufacture. So he said he saved more than 2 weeks manufacture time just in me building the 3D solid model.
Just to clarify,
before I even. Well, the thing is that when you're trying to draw something complex in 2D, you're basically trying to get these 3, let's say that we're using 3 views, right? Because you usually have 3 views, plan, and they have to all agree exactly for you to be able to build the solid part. And they didn't. And then the other thing that was a lot worse, come on in, no worries. The other thing that was a lot worse was that the DXFs that they had provided for their profiling, so they were a company that profiled a lot of their stuff out of sheet metal and then folded it or bent it and then fabricated it, welded it all up. A lot of their fabrications were, they'd bend this and it wouldn't end up the way they thought it was going to end up because their profiles were wrong. So when we bent them in sheet metal, and that's the beauty of Solid Edge and SolidWorks and all these fancy CAD systems, is you can do that. You can, you know, take a flat pattern and bend it up and you see what it ends up like. And if it's a simple bend, in other words, it's ruled bend, it'll actually be pretty accurate, you know, just out by the neutral axis, where you define the neutral axis in the context of the bend. Does that make sense to everyone? You're putting one side in compression, the other side in tension. As long as you know where that neutral axis is, the bend's going to be accurate. And we were showing him all over the place where those weren't right. You know, we bend them, and it didn't come out to what he wanted his machine to look like. So he said, look, I'm willing to pay for you right now because you've already saved me, you know, probably $5,000 in every build that I do, you know. Anyways, that was fine. But then I got to my challenge. So what are the loads? So how do you develop loads for something like this? Well, it's a really good question in my mind. Is half of any machine analysis is what are my loads? What are my loads in this context, you know? Other things like temperature and all kinds of things come into it, but from a structural analysis point of view, the biggest questions are what are my loads and what are my restraints? And when you talk about loads and restraints, they're swappable. And people don't get that. They think, well, it's fixed into the wall in concrete, so that's a boundary condition, that's a restraint. I'll put that in my FE as a restraint, and I'll put my load out here. Well, it actually can go either way. From an FEA point of view, it doesn't give a shit whether something's a restraint or a load. And in fact, the Saint-Venant's theorem tells us that we can analyze anything, and if we're far enough away from the restraint, it'll be accurate. So it's the restraints that always cause us the problems. And so if we swap them, sometimes we can model half the structure assuming that's the restraint, and then the other half of the structure assuming that's a restraint. But a better way is to get your restraints right. Motovated is really good at getting restraints right, and that's one of the things I teach more than anything else when I teach computational solid dimension. So I do some guest lectures for Canterbury University as well, in and around Computational Solid Mechanics. They're courses. And in those courses, I talk a lot about singularities, because that's the other thing that really bites people in the butt, and I talk a lot about boundary conditions. How do you model something accurately in a boundary condition? So once again, got distracted. Sorry, gents. Going back to this machine, so I had those challenges. How do I get the loads, and how do I restrain it? How do I restrain it realistically compared to what it was in the real world? And it was easy. You know, he was really worried about that. The guy that had referred me said it's impossible. Everyone that was doing the engineering for him up in the Waikato was telling him, you can't determine these loads. Who knows? You know, it could be anything. Bullshit. It's attached to an excavator. The excavator has 5,000 psi available pressure. By the time it gets to the end of the boom, it's nothing like that. I can develop the loads, and I know what a tree weighs. You know, I know what the force is on my cutting bar. I know what the drive wheel power is in those wheels. I want limiting loads. I don't want maybe exact load. I don't really care about that. What's the worst that it can be? You know? Because it will be. One day, it'll be worse. It'll be the worst load. So that's what I'm always interested in. What's my worst case loads? How do I develop them? Well, I know what 5,000 psi in that hydraulic motor will do. I know what 5,000 psi in that ram will do. That hydraulic cylinder.
So
Go ahead.
What do you mean by boundary conditions? All those maximum loads?
Those are forces, so boundary conditions are quite different. Because now I've got to restrain that structure from moving under all those loads. I've put all these loads on it, and they come from drive wheels, they come from the knife arms. So these arms here strip the limbs off. I'll describe this for people that don't know this thing. There is that hanger bracket there attaches to the end of an excavator boom. And an excavator offers this thing up against the tree, and then these knife arms come and they grab a hold of it to hold it and lift it as the chainsaw that you can see in the bottom comes out and cuts the bole of the tree off. Once the bole of the tree's off, the excavator actually lifts the tree in the air. So, and at that same time, it releases the hanger bracket, and the tree falls, and the excavator is just holding up the butt of the tree. Does that make sense? So the rest of the tree hits the ground, bounces, boom, 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 and it's sitting there. Then those drive wheels come in and they start dragging the tree through those knife arms and taking off every limb as it goes up the tree. So it goes and sweeps along the tree and takes off all the limbs. So that's the delimb part. Feller is the felt, you drop it and then you delimb it. So this is a Feller-Delimber. And then we also had cut to length, so we put saws on the top of this later. So we could cut those things off at 2 meter lengths or whatever was convenient for the guy that's going to take them away. So this is a very multi-purpose machine, a amazing machine, kind of thing that I love New Zealand for, because we develop these things better than anyone else in the world. The best Feller-Delimbers are all developed within 30-mile radius of Tokoroa. You know? It's amazing. We're a small country in the end of the world, and we create the best Feller-Delimbers in the world. And they're used everywhere. They're used in America, they're used in Europe. So I got the opportunity with this one to really get in, to learn something and to teach him something. And So anyways, I applied the loads, applied the boundary conditions. I got my analysis run. I sent him a plot and I said, this is where it's breaking. He said, yep. Now what do we do?